Rise and shine, porcupines. It's Algebra with Al time, and I'm your host, Al Rosetti. So today, we're talking about slope and rate of change. So, students, you will be able to identify slope. You will be able to calculate slope. The concept is y equals mx plus b, or linear equations. The skill is being able to graph them. So what do you say we get started? Okay, so first things first. To be able to identify slope, we have to be able to calculate it mathematically. There's a simple formula, y1 minus y2, x1 minus x2. Now look, if we were in my classroom, I would never show you x1, x2, y1, y2. Those sub numbers have nothing to do with it. In fact, to me, they're even more confusing. But as long as we take the y minus the y and the x minus the x in the same order, we'll always get the same answer. Okay, so let's take a look at it. So the first one, we've got 5 minus a negative 3. Okay, so key here, being able to add and subtract positive and negative integers, folks. Don't let that be the reason we don't get the correct answer. So subtracting a negative, we have to add it together. So we get 8 over 2. Let's simplify that, right? 8 over 2 is what? 4. Okay? All right, number 2. 2 minus 0 and 0 minus 3. Now look, so 2 minus 0 is 2. 0 minus 3 is negative 3. So the slope is negative 2/3. You bring the negative, even though it's in the denominator, it makes the whole fraction negative. So put it out in front of the fraction. Don't leave it down the bottom. Even though it's still correct, teachers are going to wonder if you really know what you're talking about. Any negative, top or bottom, move it out in front of your fraction. All right, let's go to number 4. All right, so we have what? On number 4, negative 5, right? And that's minus a negative 2. Here we go again, positive, negative integers. You're going to add the 2, right? So that makes that negative 5 plus 2, opposite signs, we're going to subtract. You get negative 3 over 4. Okay, now, see how the negative 3 over 4, we want to write that with that negative out in front of the 3/4, right in the middle. Okay, number 5, still working on finding slope using y1 minus y2, but like I said, y minus y divided by x minus x, as long as you do it in the same order, you're fine. You can even go in reverse order as long as you do both of them in the same direction. You'll get the same answer. I don't think most kids know that. All right, so now look at number 5. As soon as you see that the denominator is 0, you can stop right there. That is the one thing that is undefined in mathematics. One of the couple of things, I should say. But it's still a line. Even though 6 over 0 is undefined, that line is a vertical line, straight up and down. It's still a line. It's just not defined as far as the slope goes. All right, so we're looking at number 6. Negative 4 over 2, that's a positive 3/4. Okay, let's keep going on. So really, this is just kind of a lot of repetition here, but for some reason, we seem to make a lot of mistakes on this, and it comes back to understanding positive and negative integers. See how everything, that's like Algebra 1, first semester, but everything comes back to that because there's only addition, subtraction, multiplication, and division. That's all there is. I don't care how challenging the problems are. All right, so we're looking at 7. I got 5 minus 7 over 4 minus 2, negative 2 over positive 2. So the slope will be what? Positive 1, or negative 1. M equals negative 1. You have to simplify it. All right, number 8. So negative 2 and negative 4, and we got 3 and 2. So what are the y's? The y's are negative 4 minus 2, right? Keeping in mind our integer rules. Same signs, add them together, keep the sign. So it's negative 6 on top, right? Down the bottom, negative 2 minus 3, same signs, add them together, is negative 5. Okay, now both the top and the bottom are negative numbers. So what does that mean? Anytime we're multiplying or dividing the same signs, in the end, that slope will be positive. Okay, so a positive 6 over 5, because same signs, Multiplication and division, make sure you don't get them confused, can always be positive. All right, the last one. We've got 5 and 2, we got negative 3 and positive 2. So 2 minus 2 is the numerator. Do we even need to go any further? What's 2 minus 2? 0. So 0 on the numerator means the slope is 0. We don't need to do any more math. Now what does that look like on a graph? That's a straight line horizontal. That is defined. That slope is 0. Okay, so I did all the steps just because, but if you see top or bottom is 0, just go ahead and move on. All right, so now what we're gonna do, okay, we gotta find the rate of change. And when people talk about the rate of change, they're talking about slope. But specifically when they say rate of change, they're talking about the change in y and x from one point to another point on the graph. What is the change? So the change in y would be how many up or down from that point. The change in x would be how many left or right from that point. That's what they're talking about when they say rate of change. All right, so there's a couple ways you can do it. You can use the formula just like we did, but if it's graphed, why not just draw what we call a slope triangle? Okay, so you're gonna draw a right triangle from the 2 points attached to that line, and you're just gonna count, okay, how many units did I go to the right? Okay, and then how many units did I go up? I went 5 units to the right and 2 units up. So the slope of that line is 2/5. Now here's the math, so I can prove it to you so you don't think, let's do the math on it. So we have 0 minus 2, right? And then 0 minus 5, now that's negative 2 over negative 5, but that makes it a positive 2/5. And that's what I just got from drawing that right triangle. So is it easier if it's graphed? I think it's just easier to draw your triangle. Why do the calculations? If it's not graphed, well then it's easier to use the formula, obviously, than to draw a graph. But if it's graphed, take advantage of it. Heck, that's the way I would do it. All right, so let's look at number 11. So from those 2 points, what did I do? I went down 1 from the y, so the change in y is down 1. And then I went to the right 2, down 1 over 2. Now here's the only thing you have to remember that you won't get if you're graphing it or drawing the triangle on a graph. It won't come up negative. You just have to know if the line is going from left to right, down, that's a negative slope. So you don't need to do the math, but if you did the math, it would calculate to a negative. But look at the picture of the first graph. Come on. You can identify visually that that one's going up, so that's positive. The second one's going down, so that's negative. Do you really need to calculate to come up with a negative? I don't think so. See the lines going down from left to right, no matter what, it's a negative slope. And there's the math to prove it. Negative 1/2 is what I came up with when I did the calculation. But what I'm trying to get you to do is, do some things, stop like memorizing steps and kind of just take a look at it, big picture, and it'll save you a lot of work. This is not that challenging of a concept. All right, look at number 12. Once again, let's draw a right triangle. So how many units am I going to the right and how many going up? Now obviously it's going to be a positive slope because it's going up from left to right. We don't have to worry about the negative. And I went over how many? From 0 to 5 and up 1. So slope is going to be a positive 1/5. No math, no formula, and just by looking at it. You guys get to a point you don't even need to draw the triangle, really, do you? If you understand the concept. But once again, here's the math. To do it just because. So we have what? On top, -2 minus 1. And then on the bottom, we have 0 minus 5. And in the end, we get a positive 1/5. That's what I said. We said 5 to the right and 1 unit up. All right, so here we go, a couple more. Now, one thing, if you are having to find a slope from a graph and there's no coordinates already given to you, you have to make sure that the points that you pick, the line was crossed right through it on a corner. I mean, you can do it Or it's not, but then it's a fraction, and how are you going to make that exact given this graph? So the line has got to pass through right on a corner for you to utilize those points to come up with slope, to calculate slope. So if you have to choose the points, the line's got to intersect it right on a corner, somewhere for it to matter. All right, so here we go. So I chose those 2 points, and what do? We went over 1 and up 2. So what's the slope going to be? Over 1, up 2. It's going to be 2 over 1, or just 2. Okay? Here's the math again, for those of you that just have to use the formula. So the math is what? 4 minus 6 on the top, 0 minus 1 on the bottom, and what do you get? Negative 2 over negative 1, which ends up being a positive 2 over 1, which is a positive 2. And that's what we got just by looking at the graph without having to do all these calculations. So make life easier on yourself, if you can. I don't think any teacher will argue with you if you say, hey, I just drew a slope triangle, I didn't do the calculations. All right, so number 14. All right, so we have a line. What points are you going to choose? Remember, they have to cross right on a corner. And I can see it negative 1, 0, negative 1. I can use that coordinate. And then I can also use, looks like 1, 4. It crosses right over on a corner. So what am I doing? From 0, I'm going over 1 and up 5. From negative 1, right, to positive 4. So over 1, up 5. That's 5 over 1, positive 5 over 1. That's your slope. Do I need to do the math? No. All we have to do is count the number of units. But let's do the math, because that's just what I think we need to do to make sure, you're good with it. So here we go. So in the numerator, we have negative 1 minus 5, right? And in the denominator, we have 4, or negative 1 minus 0. Do the math, you can see the calculations. 4 minus the negative 1 is what? Positive 5. And then 1 minus 0 is 1. So what did we say? We went over 1 and up 5, and that's what we have here, 5 over 1, or just 5. All right, last one. What points would you use to calculate slope? I'm thinking, from looking at this graph, I'm thinking 0, negative 4, looks like a good point. And then negative 1, negative 2. Yeah. Okay, so how many units over to the left and up? Now the key here is, on this one, do you notice something different? The last 2 graphs we did, the lines were going up from left to right. This one's going down. So even before you do your calculations, even before you do anything, you should know the slope is negative. You might even just write m equals negative, and then move on from there so you don't forget. That's probably a good idea. All right, so how many units over, how many units up? So 4 units to the left and 3 units up. So our slope is 3 over 4. We already know it's negative 3 over 4, right? We already know, because it's going down left to right, it's going to be negative 3/4. All right, let's do the math. So we have negative 5 minus negative 1 in the denominator, sorry. And in the numerator, we have 1 minus a negative 2. Keeping in mind our positive and negative integer rules, the numerator is going to be 3. And what's the denominator going to be? The denominator is going to be what? Negative 4. Okay? So what do we have? Positive 2, or positive 3 over 4. I'm sorry, positive 3 over negative 4, right? But the negative 4 makes the entire fraction negative, so it's a negative 3/4. That's what we came up with just by looking at the graph without doing any calculations. Because it's going down from left to right, it's negative. And we went to the left 4 and up 3. That's 3 over 4. All right, last one. Word problem. Now I know you guys have this big aversion to word problems, but I told you in one of the earlier sections, if there's a word problem in your unit that you're currently using or doing, to solve the word problem will be the exact same thing you've been doing. They're not going to give you a word problem that incorporates a whole bunch of different things. Whatever we were just doing, I guarantee you, is what we need to do. Whether or not you understand the word problem doesn't even matter. But what you have to understand is, what have we been doing? They're not going to have you apply something you haven't been doing to this word problem. So all we're going to have to do is take the information they give us, 7, 7,400, 11, 9,800, and come up with a slope. And we know how to we can calculate that. It's not graphed. If you wanted to graph it, you could, but no need. Like I said, if it's not graphed, use the formula. If it is graphed, draw a triangle. All right, so what do we have? We have negative 2,400 in the numerator, negative 4 in the denominator. When we do the math here, we get 600 over 1. So m equals 600. So guess what? The answer is 600, right? So the rate of change, that's what they want, is every time we move 1 unit to the right, we go 600 units up. That's the rate of change, 600 over 1. And that's it, boys and girls. I appreciate you being here. And remember, math, 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 get up and go do some math.
That's awesome, man.